Hello. The title of our research project is The Acute Effects of Anonymous Inhalants on Power Input. A slight overview. Standing power throw is also known as STP. This is a newly agreed upon power measure that was recently adopted by the U.S. Army in the Army Combat Fitness Test to measure the power of its soldiers. The purpose of our research project was to identify the effects of acute anonymous inhalant use on external power input via a standing power throw in an untrained and ungendered sample. We had wondered if anonymous inhalants have an impact when it comes to force development and if it assists with power output and standing power throw. Our methods/participants. We had 21 subjects, 14 males and 7 females between the ages of 19 and 22 participate. We had measured out the height and weight of these participants. And for females, as far as height goes, the measurements came out to 166 centimeters, which equaled out to a standard deviation of 4.70. Our males measured out to 180 centimeters, which equaled out to a standard deviation of 12.83. Then we had weight. The average weight of the female participants was 73 kilograms, which equaled out to a standard deviation of 17.95. And our males, which came out to a measurement of 91 kilograms, which equaled out to a standard deviation of 23.28. This is a picture of most of the equipment we had used. We had used a tape measurer, a 10-pound medicine ball. We obviously used anonymous inhalant, and then our placebo was a vapor rub ointment. We had 21 subjects. Were split up into 3 groups, 11 for the control group, 5 for the anonymous inhalant group, and 5 for the placebo group. The stimulants were placed approximately 12 centimeters away from the nostrils, and the subjects were instructed to deeply inhale the stimulant once before proceeding with a throw attempt. Before testing, each participant was instructed to perform a standard dynamic warm-up. This warm-up didn't really include much. It was more so of stretching. Two practice throws were allowed to be executed during the warm-up as well to familiarize themselves with the equipment. Testing took place in a single 30-minute session with 5 minutes given for the actual procedures and a minimum 3-minute recovery period between repeated trials. 2 trials were performed for each test, and the best of 2 throws were used for the analysis. After the 2 trials were completed for each group, the participants in the anonymous inhalant group switched with the placebo group and continued with 2 more trials for their new lanes. Those who were in the control group for day 1 were done with the testing after the trials. On the second day of testing, those who were in the control group were split in half and put into either the placebo or anonymous inhalant group. Those who were in the placebo and anonymous inhalant group on day 1 were combined to form one control group for day 2. The same procedure that was done on day 1 was then carried out again on the second day. Some of our methods/procedure steps. We had instructed participants to face away from the starting line. And then we waited for the participant to grab the 10-pound medicine ball at the hips and place their heels behind the start line, while the assessor, which was the people that participated in the group, held the type of stimulant. If there was one the participant inhaled, the assessor watched the participant rapidly squat down while they held the medicine ball and threw it overhead. The assessor measured the distance of the throw in meters from the starting line to the center of the landing point. And in this slide, it's just a picture of how it was all set up. Down to the far left, the farthest group was the control group. The middle group was the placebo group. And then the group standing on the end, furthest to the right, is the anonymous inhalant group. Some of our methods/statistical analysis consisted of the mean and standard deviation for all the distances measured for each lane was calculated. Each lane was then compared to the other 2 lanes individually by utilizing multiple paired t-tests to assess any significant differences between the independent variables. The alpha level for this study was set at 0.05. And then this is a picture of the relationship between the various standing power throws. You can see the data for our control, placebo, and enantiomer inhalant. The control group mean had came out to 9.05 with the standard deviation equaled out to 3.02. The placebo group, the mean totaled out to 9.05 meters and the standard deviation equaling out to 2.83. The enantiomer inhalant mean equaled out to 9.9 meters with a standard deviation equaled out to 3.03. Our control versus placebo p-value was 1, and then our control versus enantiomer p-value was 0.58, and then our placebo versus enantiomer group was the p-value equaled out to 0.61. Our final calculations of the p-values were all larger than 0.05. So this means that there's no significant difference between the enantiomer inhalant and its impact on the standing power throw when compared to the placebo group or the control group. And just for a little open discussion, our limitations that we had, anybody who inhibited asthma or other respiratory issues and or any other injuries that would prevent them from throwing and jumping, we had them sit this one out because it would be hard for them to participate. We didn't come to a conclusion on how enantiomer inhalants may affect a more general population, and this study confirms that enantiomer inhalants show no improvement in performance on the standing power throw in a sample of untrained and ungendered samples. Future research may attempt to analyze the effects of enantiomer inhalants on trained populations using this standard power throw to measure power output. And then we have our references. Thanks.